We're going to talk about standard form of a linear equation. I'm going to walk you through how to complete and what to write in your foldable that will serve as your notes on standard form. The first thing I want you to do is take your foldable and fold it in half, hamburger style, so that the page you see that says Method 1 and Method 2 on it is your front page. So, what is standard form? Standard form looks like the following. It's an equation that looks like ax plus by equals c. So, when given standard form, there are two methods to follow that can help you graph this linear equation. Method number 1. Convert into y equals mx plus b form, so our slope-intercept form. And when you convert it in this, you need to remember that your m is your slope and your b is your y-intercept. So when we graph this, we're going to plot our y-intercept, and then we're going to plot our next point according to what the slope is. I want you to write the convert to y equals mx plus b in that box, and make sure you do label your m and your b, your slope and your y-intercept. Underneath of that box on the left-hand column, we're going to write 3 steps in order to solve or convert from standard form to y equals mx plus b, slope-intercept form. So, step number 1. Step number 1, you want to move your ax term, that first term you see, that ax term, to the other side by adding or subtracting it. Step 2, again, I want you to place this under step number 1 in that left column. Step 2, you're going to divide everything by b. And then your third step is going to be your graphing step. When you graph, the first thing you're going to do is graph the y-intercept and use the slope to find another point. So this is our first step. If given an equation in ax plus by equals c form, which is called standard form, if I asked you to graph it, the first thing or the first method you could use is to use the y equals mx plus b slope-intercept form, something you're very familiar with now. Move it around so that it's in that form, and then graph the y-intercept first, and then move according to the slope. Okay, so now we're going to work on method 2 on the right-hand column. So method number 2, in the box you're going to write find and graph the x and y intercepts. Okay, so now let's talk about how to find the x-intercept. So to find the x-intercept, you're going to plug 0 in for y, and then you want to get x by itself. So why do we plug 0 in for y? Because if we drew our graph and I had a point that was on the x-intercept, anywhere on this line, this purple line, the y value is always going to be 0 because it doesn't go up or down. So we can plug 0 in for y, and then we want to get x by itself, and that value is the x-intercept. So it's always going to be written, a number, whatever you get for x, comma, 0. Okay, so let's move on to the y-intercept. The y-intercept is very similar, except we're going to plug 0 in but it's not going to be for y, it's going to be for x. And then after we do that, we want to get y by itself. So again, if I were to graph it and it's a y-intercept, it's going to be a point that's on the y-axis. So that means I'm always going to have an x0 or an x value of 0 because I don't want to go left or right. I want to stay right there, right in the middle. So that's a x value of 0. So this is always going to be 0, comma, whatever number it is that we got by itself for the y-intercept. So after you plot these two intercepts, you connect the dots and you have your line. Okay, so in the middle, we're going to use the same example, but we're going to start with method number 1. So the first thing that we need to do to rearrange is to subtract the ax value from both sides. And this ax value is 3x. So we're going to subtract 3x from both sides. So on the left, they add to give you 0, so they go away, and you're left with 5y equals negative 3x plus 15. And I wrote that x value first because I'm working towards mx plus b form, and so whatever is married to that x, touching that x, it needs to go in the first position. Then what we do is divide everything by our b term, and that b term does not include y because we need y to stay, so that just is our 5. So notice how each part gets divided by 5. Over here, the 5's divide to give you 1, so they cancel. So we have y equals negative 3 over 5x plus 3. Okay, so now we need to identify our slope. And our slope is negative 3 over 5, so it's going to be a negative line. And we need to identify our y-intercept. So our y-intercept is going to be 0, 3. So when we graph, we start with the y-intercept. So at 0, 3, I'm going to put a point right here. And then my slope is negative 3 over 5, so I'm going to go down 3 to the right 5. And here's my next point. So let's see if I can draw a straight line. So I connected the points, and I'm going to draw my tails on either end because the line keeps going. Okay, now let's look at the same problem, but we're going to solve for the x and the y-intercepts. Okay, so we're going to start with the x. So remember, we're going to plug 0 in for y. So we're going to have 3x plus 5 times 0 equals 15. 5 times 0 gives you 0. So we're left with 3x equals 15. And to get x by itself, we're going to divide both sides by 3. And we're left with x equals 5. So since 0 is our y value, then that means we're going to have 5, 0, and this is what we're going to plot on our graph. But first, we need to find the y-intercept. And with the y-intercept, we're going to plug 0 in for x. So we're going to have 3 times 0 plus 5y equals 15. 3 times 0 is 0, so we have 5y equals 15. And to get y by itself, we're going to divide both sides by 5. So therefore, y equals 3. And again, since we plug 0 in for x, our coordinate point is going to be 0, 3. All right, so let's graph both of these coordinate points right here. So my first one is 0, 3. And then my next one is 5, 0. All right, looks very similar to what we have on the left, but let's connect those dots with a straight line. Okay, so there's our line, and we're going to draw our tails on both sides. And there you have it. The graphs are exactly the same no matter which method we use.